Good morning. How are you? Welcome to the company of Amago. Today I will interview you regarding your application to the positions of data scientist. First, I will ask you some questions about machine learning general, and I will move on to interview questions of machine learning with programming focused. So the first question is, how is KNN different from k-means clustering? Thank you. K-nearest neighbors is a supervised classification algorithm, while k-means clustering is an unsupervised clustering algorithm. While the mechanisms may seem similar at first, what this really means is that in order for k-nearest neighbors to work, you need labeled data you want to classify and unlabeled points onto. K-means clustering requires only a set of unlabeled points and a threshold. The algorithm will take the unlabeled points and gradually learn how to cluster them into groups by computing the mean of the distance between different points. The critical difference here is that KNN is label points and is thus supervised learning, while K-means doesn't and thus unsupervised learning. My next question is explain how an ROC curve works. The ROC curve is a graphical representation of the contrast between true positive rates and the false positive rates at various thresholds. It's often used as a proxy for the trade-off between the sensitivity of the model, true positives, versus the fallout or the probability it will trigger a false alarm, false positives. My next question is define precision and recall. Recall is also known as the true positive rate, the amount of positives your model claims compared to the actual number of positives there are throughout the data. Precision is also known as the positive predictive value, and it is a measure of the amount of accurate positives your model claims compared to the number of positives it actually claims. It can be easier to think of recall and precision in the context of a case where you have predict that there were 10 apples and 5 oranges in a case of 10 apples. You have perfect recall, there are actually 10 apples and you predict there would be 10, but 66.7% precision because out of 15 events you predicted, only 10 are correct. My next question is what's Bayes' theorem? How is it useful in machine learning context? Bayes' theorem gives you the posterior probability of an event given that what is known as prior knowledge. Mathematically, it's expressed as the true positive rate of a condition sample divided by the sum of the false positive rate of the population and the true positive rate of a condition. Say you have had a 60% chance of actually having a flu after a flu test, but out of people who had the flu, the test will be false positive 50% of the time, and the overall population only has a 5% chance of having the flu. Would you actually have a 60% chance of having the flu after having a positive test? Bayes' theorem says no. It says that you only have 6.6 times 0.05 true positive rate of a condition sample divided by zero point 0.6 times 0.005 plus zero point 0.5 times 95 equal to 5.94% chance of getting a flu. Bayes' theorem is the basis behind a branch of machine learning that most notably includes the naive Bayes classifier, naive Bayes classifier. That's something important to consider when you are faced with when you are faced with machine learning interview questions. So my next question is, what is naive Bayes naive? That's a great question. Despite its practical applications, especially in text mining, naive Bayes is considered naive because it makes an assumption that is virtually impossible to see in real life data. The conditional probability is calculated as the pure product of the individual probabilities of components. This implies the absolute independence of features, a condition probably never met in real life. My next question is explain the difference between L1 and L2 regularization. Thank you. L2 regularization tends to spread error amongst all the terms, while L1 is more binary and sparse, with many variables either being assigned as a 1 or 0 in weighting. L1 corresponds to getting a Lagrangian pirate on the terms, while L2 corresponds to Gaussian pirate. My next question is quite personal. What's your favorite algorithm, and can you explain it to me in less than a minute? My favorite algorithm is network flow algorithm. I can explain it to you in a minute, in the sense that network flow algorithm calculates the flow between each of the nodes, and based on the difference between the flow into and flows out of, and also you have a sink and you have a source. And network flow algorithm is a algorithm that uh, takes you iteratively and from the flow to the sink, to the source to the sink, and then all in all together it has a very good algorithm that's a scale very great. My next question is what's the difference between type 1 and type 2 error? Type 1 error is a false positive, while type 2 error is a false negative. Briefly stated, type 1 error means claiming something has happened when it hasn't, while type 2 error means that you claim nothing is happening when in fact something is happening. So, a clever way to think about this is to think of type 1 error as telling a man he is pregnant, while type 2 error means that you are telling a pregnant woman she isn't carrying a baby. My next question is what's a Fourier transform? A Fourier transform is a generic method to decompose generic functions into a superposition of symmetric functions. Or as more as it puts it, given a smoothie is how we find a recipe. The Fourier transform finds the set of cycle speeds, amplitudes, and phases to match any time signal. A Fourier transform converts a signal from time to frequency domain, and is very and it's a very common way to extract features from audio signals and other time series as data such as sensor data. What's the difference between probability and likelihood? The answer depends on whether you are dealing with discrete or continuous random variables. So I will split my answer accordingly, and I will assume that you have some technical details already. If in the case of discrete variables, when we model a real life stochastic process, we don't really know. We want to know the natural estimation process to choose that the value want to maximize the probability that we want to observe. Oh, and for continuous random variable, in this situation, we cannot technically assert that we can find the parameters that maximize the probability that we observe O, as we maximize the probability density function associated with the observed outcome O. So the difference between the likelihood and probability is is that this is kind of question um, that depends on the data and also the model. My next question is what is deep learning and how does it contrast with other machine learning algorithms? Deep learning is a subset of machine learning that is concerned with neural networks, how to use back propagation and certain principles from neuroscience to more accurately model large sets of unlabeled and semi-structured data. In that sense, deep learning represents an unsupervised learning algorithm that learns representations of data through the use of neural nets. My next question is what's the difference between a generative and discriminative model? A generative model will learn categories of data, while a discriminative model will simply learn the distinction between different categories of data. Discriminative models will generally outperform generative models on classification tasks. My next question is what validation technique would you use on a time series dataset? My answer of that is instead of using standard k-fold cross validation, you have to pay attention to the fact that the time series is not randomly distributed data. It is inherently ordered by chronological order. If a pattern emerges in later time periods, for example, your model may still pick up on it, even if the effect doesn't hold in earlier years. You will want to do something like forward chaining, where you'll be able to model on past data than looking at forward facing data. My next question is, how is a decision tree pruned? Pruning is what happens in decision trees when branches that have weak predictive power are removed in order to reduce the complexity of the model and increase the predictive accuracy of a decision tree model. Pruning can happen bottom up and top down, while approaches such as reduce error pruning and cost complexity pruning. Reduce error pruning is perhaps the simplest version. Replace each node. If it doesn't decrease predictive accuracy, keep it pruned. While simple, this heuristic actually comes pretty close to an approach that would optimize for maximum accuracy. My next question is, what's more important to you, model accuracy or model performance? Well, it has everything to do with how model accuracy is on only a subset of model performance. And as that, sometimes this is a misleading one. For example, if you want to detect fraud in a massive dataset with a simple sample of millions, a more accurate model will most likely predict no fraud at all, if only a vast minority of cases were fraud. However, this would be useless for a predictive model. A model decided to find fraud that asserted there was no fraud at all. Questions like this help me demonstrate that I understand model accuracy isn't the be all and end all of model performance. My next question is, what's the F1 score and how would you use it? The F1 score is a measure of model's performance. It is a weighted average of the precision and recall of a model, with results tending to 1 being the best and those tending to 0 being the worst. You will use it in classification tests where true negative doesn't matter much. How would you handle an imbalanced data set? An imbalanced data set is when you have, for example, a classification test and 90% of the data in one class. This leads to one problem. An accuracy of 90% can be skewed if you have no predictive power on the other category of data. And here's a few tactics to get over the hump. First of all, you have to collect more data to even the imbalances of in the data set. The second is you have to resample the data to correct for imbalances. The third is you have to try a different algorithm to altogether on your data set. What's important here is that you have a keen sense of for what damages on imbalances can cause and how to balance that. My next question is, what should you use classification? When should you use classification over regression? My answer is that classification produces discrete values and datasets to extract categories, while regression gives you continuous results that allows you to better distinguish between individual points. You would use classification over regression if you want your results to reflect the belongings of data points in your datasets to certain explicit categories. For example, if you want to know whether a name was male or female rather than just how correlated they were with male and female names. So, name an example where ensemble techniques might be useful. Ensemble techniques use a combination of learning algorithms to optimize better predictive performance. They typically reduce overfitting in models and make the model more robust. Now, I can list some examples of ensemble methods like bagging, boosting, and backoff models method, and demonstrate how they would increase predictive power. My next question is, how do you ensure you are not overfitting with a model? This is a simple restatement of a fundamental problem in machine learning we see every day: the possibility of overfitting training data and carrying the noise of that data through the test set, therefore providing inaccurate generalizations. There are three main problems to avoid overfitting: keep the model simpler, reduce variance by taking into account fewer variables and parameters, thereby removing some of the noise in the training data. Use cross-validation techniques such as k-fold cross-validation. Use regularization techniques such as LASSO to penalize certain model parameters if they are likely to cause overfitting. My next question is, what invariant approaches would you work to gauge the effectiveness in a machine learning model? I will first split the dataset into training and test sets, or perhaps use cross-validation techniques to further segment the datasets into composite sets of training and test sets within the data. And I should then implement a choice selection of performance metrics. Here's a fairly comprehensive list. You would use measures such as F1 score, the accuracy, and the confusion matrix. What's important here is to demonstrate that I understand the nuances of how a model is measured and how to choose the right performance measures for the right situations. My next question is, how would you evaluate a logistic regression model? To evaluate the logistic regression model, we first of all we have to learn what that is. So we have to learn how to geometric distinguish the positive examples from negative examples when given a training of data points. And then I will want to make a prediction on the new and yet unseen data points. And to evaluate the effectiveness, um, we want to we want to also understand that the result of the prediction is always represented as the number between 0 and 1, when 0 means the predictive predicate is false for data point, and 1 means the predictive is true, and zero point 0.5 means we can't really say. So what's the kernel trick and how is it useful? The kernel trick involves kernel functions that can enabled in higher dimension spaces without explicitly calculating the coordinates of points within that dimension. Instead, kernel function computes the inner products between the images of all pairs of data in a feature space. This allows them to be very useful to be there allows them the very useful attribute of calculating the coordinates of higher dimensions while being computationally cheaper than the explicit calculation of set coordinates. Many algorithms can be expressed in terms of inner products. Using the kernel trick enables us to effectively run algorithms in a higher dimensional space with lower dimensional data. Thank you. So this is the end of my first section of interview. So we will take a rest of about 5 to 10 minutes. After that, I will ask you some interview questions regarding the machine learning with focus on the programming. Thank you very much.